Hello everyone, welcome to this video. In this video, we'll be talking about slope of a line when 2 points are given to us, right? So here in the previous video, we already saw when a point x1, y1 and some angle theta is given to us, right? Then we can calculate the slope by using the formula of tan theta. That is so simple, and it is not defined whenever theta was equal to 90 degree. Now and using the slope and using one point, we are able to calculate the equation of line. That we have not studied, but you know we can do it, right? Now here we have 2 points. Using these 2 points, are we able to calculate the slope? Because if you know the slope and one point is known to you, then you can directly have knowledge about your equation, right? Straight line. So here we have these 2 points. So these 2 points are given on some line L, which makes an angle of theta degree. So now we have 3 cases. Whenever this angle is acute, so that means it is less than 90 degree, right? If the angle is equal to 90 degree, or if this angle is greater than 90 degree, so that means it is obtuse, correct? And if your angle is 180 degree, that would be equivalent to talking about 0 degree, which is included in this case. If your theta is greater than 180 degree, right, so it would be included in this case, right? It is lying between 180 and 270, and if it is 270, it is equal to this case. If it is greater than 270 and less than 360, it is equal to this case. So hence we only have to discuss about the 3 cases: this less than 90, equal to 90, and greater than 90, correct? Okay, now let's take the case number 1. Here in this case, when your angle theta is acute, so here we assume our line to be like this, correct? It could have orientation either like this, or it cannot be a vertical line. It could be less than this only, right? It could be any of these. So here for this particular orientation, whenever your angle theta is acute, then what you can do, you can you have these 2 points P and Q given to you. For these 2 points here, the coordinates are also given to us: x1, y1, x2, y2. So you can draw a horizontal line parallel to x-axis, and you can draw a vertical line parallel to y-axis, dropping from the point Q, right, at R, and it meets this horizontal line at M. So you see this angle is also 90, this angle is also 90 here, correct? And if this angle is theta, then this angle is also theta. Why? Because this line and this line, they are parallel to each other. So these 2 angles, they form the corresponding angles. So here the slope of line would be, you know, calculating using this definition: m is equals to tan theta. So let's mark this as equation 1, which is our definition. Now here we know this angle is theta, correct? This angle is known to be theta. Why? Because it is corresponding angle with angle PNR. So, and moreover, this triangle, if we are talking about this triangle, this forms a right angle triangle. You can clearly see, if this forms a right angle triangle, so from here we wanted to know our slope. So we wanted to calculate the value of tan theta, and you see we have theta here. So in this right angle triangle, we can make use of trigonometry and calculate tan theta. So tan theta, you know, it is perpendicular upon base. So what is the perpendicular here? It is this much distance. And what is this distance? This distance is this distance minus this distance, right? And what is this longer distance? It is your y2 coordinate, correct, according to this. And your this one distance, it is your y1. Why? Because this coordinate is y1, and this horizontal distance is same as this distance, and it is y1. So this much distance would be what? It would be y2 minus y1. So that means your the value of perpendicular QM would be y2 minus y1. And similarly, the value of base, what would be this value? PM. It would be calculated again using calculating this larger value, which is what? This point is this distance would be like this, and it would be same as calculating this distance, and this distance, you know, is x2. So therefore this distance is also x2, correct? Once you know this complete distance, now you know what is this much distance. It is the same as this much distance, correct? And what is this? This is x1. So this distance is x1, so the remaining distance here would be calculated by having x2 minus x1. So it is x2 minus x1. Hence let's mark this as equation 2. Now you can see in equation 2 and equation 1 we have the value of tan theta, which is y2 minus y1 divided by x2 minus x1. So we can equate the two values and hence we obtain the value of the slope, which is y2 minus y1 divided by x2 minus x1. This you have to remember. Correct? This is for the first case when your angle is acute. Now in the second case, when your angle is 90 degree, then you already know the slope is not defined in that case, because whenever your angle is 90 degree, tan 90 degree is not defined. Hence in this case the slope is not defined. In the third case, when our angle theta is obtuse, the orientation of line, it would be either like this, or this, or this, or this, or this, like this, right? It cannot move below 90 degree, right? So it would lie here only. Okay, so once you know this thing, so your angle theta would be this angle which starts from the baseline x-axis and goes in the anti-clockwise direction. So here for this angle theta, you have one point this as P, another point this as Q, right? The coordinates of P are given to be x1, y1, coordinates of Q would be given as x2, y2. So here you see the slope of this line is tan theta, right? That you know by definition. So let's mark this as equation 1. Now this is your angle theta, correct? So what would be this angle? It would be 180 minus theta by the linearity property, because they form a linear pair. And then if it is 180 minus theta, you can draw a line horizontal parallel to this x-axis, right? So therefore whatever is this angle, the same would be this angle, because they are corresponding angles. Hence this was 180 minus theta, so this also has to be 180 minus theta, correct? And moreover, you can drop down a vertical line from Q so that its length would be y2, correct? And this length would be equal to how much? You see the complete length here is x1, this much length is your x2, so this much length is x1 minus x2. Similarly here the complete length is y2, right? This much, the smaller portion length is y1, hence this difference would be y2 minus y1. Why I wanted to have all of them? Because you see we will be needing this and we will be needing this. Now because in this triangle MPQ, this one, right? This is a right angle triangle, we can clearly see. And here you know the value of this angle MPQ is equal to 180 minus theta, right? So from here, what is the value of theta? It is 180 degree minus angle MPQ. Why we require theta? Because that will give us our slope, right? So we require theta. So what would be your tan theta? It would be substituting the value of theta as 180 degree minus angle MPQ. Now according to the rules of trigonometry here, tan of 180 degree minus some other angle, let's say alpha, this would be equal to how much? Minus tan alpha. Because we are now 180 minus some angle, we are now in the second quadrant here. In second quadrant the value of tan is negative, and for 180 degree tan will remain tan, correct? So your tan 180 degree minus some angle would become minus tan of angle MPQ, right? So we'll keep this minus as such. Now what is the value of tan angle MPQ? What is angle MPQ? This is this particular angle. For this particular angle, right, let me highlight it also, this angle. For this angle we wanted to calculate tan of this angle, so it would be equal to perpendicular divided by base. So what is the perpendicular corresponding to this? It is this QM, right? It is this QM, and the perpendicular corresponding to the base corresponding to this angle would be this MP, right? So you have QM, you have MP with you. The value of QM we have just calculated it to be y2 minus y1, and the value of MP we have calculated it to be x1 minus x2. So you can substitute the values here, right? Once you substitute the values, you can see we can shift this negative sign in the denominator so that it would become minus x1 plus x2, or you can rewrite it like this. Hence this is the value of tan theta. So the value of slope from here comes out to be equal to y2 minus y1 divided by x2 minus x1. Hence this is the value of slope, and you see this value of slope is exactly equal to this value of slope. Hence you see, we only, whenever either our angle is acute or obtuse, we will get the value of slope m, which is tan theta, as equals to y2 minus y1 divided by x2 minus x1 whenever 2 points P and Q are given to be on line. Correct? So I hope you understood this article well. Well, that is it for this video. Thank you for watching.